Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. So for today we are going to continue our hypothesis testing for the difference between two population mean. Okay, specifically for dependent sample. Okay, last week we already looked into the independent sample. Okay, now we will continue on the dependent sample. So if you still remember, what are the difference between the independent and dependent sample? Okay, so for the dependent sample, okay, I recap. The dependent sample means for example, you have one group of population that can that be tested twice. Okay, for example, I'm taking the score of the AP 220 student, okay, for STA 408 marks, okay, and then I want to compare whether their score before they attending certain statistic course, whether the score were increasing or decreasing. Okay, so that is meant by the dependent sample. Okay, from one population we measure that population twice. Okay, so before we go further into the example, let's take a look into the 5 steps that involve in testing the dependent sample. Okay, so as you still remember, our first step is we need to constructing the null hypothesis and the alternative hypothesis. Okay, so again, the procedure is still the same, okay, for all the cases that we already look. So we have 3 types of hypothesis that can be tested, either left tail, right tail, or two tail. Okay, so for null hypothesis, you should write as mu d equals to 0. Mu d is referring to the difference between the measurement from of the first measurement and the second measurement. Okay, so we put as mu d equals to 0. Okay, and then for the alternative hypothesis, for the left tail, we put it as mu d less than 0. For the right tail, mu d greater than 0. And for the two tail, mu d not equals to 0. And then the second step, we have the you have to calculate the test statistic value. So the test statistic value, if you still remember, the formula is given by T equals to D bar minus D naught, or D naught here is referring to this value. Okay, if you are putting any other value, so this value will be replaced the D naught. Okay, if not, we just put it as 0 value. So T equals to D bar minus D naught over SD over square root N, where the D bar is, you need to find the summation of the difference, okay, for the paired sample and divide by N. So we will get the D bar, and then you need to calculate the standard deviation of the difference. Okay, the formula is given by 1 over N minus 1 times summation of D square minus summation D over N squared. And don't forget to square root the answer because we want the value of the standard deviation. Okay, and then the step number 3, we have the critical value. So for the left tail, the critical value is T alpha with the degree of freedom N minus 1. Okay, you don't have to divide the alpha with 2 because this is the left tail. Okay, and then for the right tail, the critical value is given by T alpha with degree of freedom N minus 1, but for the two tail test, you need to divide the alpha by 2. So we have plus minus value of T alpha over 2 with degree of freedom N minus 1. Okay, and then for the decision rules, okay, for each of the tests that we will use, okay, so you can refer this decision rule. Okay, for the left tail test, the decision rules is reject hash naught if the test statistic less than the critical value. Okay, and then for the right tail, we reject hash naught if the test statistic greater than the critical value. And whereas for the two tail test, we have option, okay, for the decision rule. Either we reject H0 if the test statistic less than the critical value, or test statistic greater than the critical value. So since we have the from the positive side and the negative side, okay, so we will reject when the test statistic value falls in the critical region, okay. Other than that, you also can use the p-value approach, okay, by comparing the p-value and the value of alpha. So we will reject H0 if the p-value less than alpha. So remember, if we use the p-value approach, there is only one rules that should be applied for the left tail, right tail, or the two tail. Okay, and lastly, you need to make the decision and the conclusion. Okay, now let's take a look into example 4.21. Okay, many engineering students are having problems in data analysis using statistical software. A professor who teaches statistics for engineering course offered a 2-day workshop on this topic. The following table gives the test score of 7 engineering students before and after they attended the workshop. Okay, so this example are referring to the dependent sample because, okay, the test score will measure on the same student, okay, on the same 7 engineering student, okay, first before they attend workshop, and then the second round is after they attended the workshop. Okay, so what we want to test here is we want to test at 5% whether attending the workshop increases the test score. Okay, so you need to imagine, okay, what are meaning that by the attending the workshop increases the test score, meaning that the score before attending the workshop were less than, okay, less than or smaller than the score after they attended the workshop. That is mean by increases the test score, okay, meaning that score before attended the workshop were less than the score after attending the workshop of the statistic course. Okay, so as usual, you need to follow the 5 steps that involve in conducting the hypothesis testing. Okay, but before that, what you need to calculate here is you need to find first the value of the d bar and the standard deviation of the difference. Okay, so how to calculate the value of d bar and standard deviation of the difference? Okay, so first you need to calculate the difference. Okay, the difference here meaning that we subtract the value of before and after. Okay, so you subtract the value of 56 minus 62, we get negative 6. 69 minus 73, we get negative 4, and so on. Okay, and then you find the value of the d square. For we squared the value of the difference, okay, one by one. Okay, and then we find the value of summation of d equals to negative 33, and summation of d square equals to 347. Now we can calculate the value of d bar, okay, where the value is given by negative 33 divided by 7. 7 is our n, so we get the d bar equals to negative 4.7143. And then we calculate the value of standard deviation of the difference, so we get the value of 5.6484. Okay, so again, I would like to inform here, there is no wrong. Okay, it doesn't matter, tak ada masalah kalau awak nak buat after minus before. Okay, dia tak ada masalah, it will accepted. Okay, tak ada masalah untuk awak buat after minus before. But if we are following the question here, because the question asking you to test whether the attending the workshop increase the test score, meaning that if before minus after if the terms were increasing the test score, meaning that the score before is less than score after. Okay. Okay, so let's go for the first step. So the first step is you need to formulate, or you need to construct the hypothesis. So we have the null hypothesis here is mu d equals to 0. Okay, what does it mean by mu d equals to 0? Meaning that the score before is equal score after. This is no changes. Okay, after you attending the workshop. And then the alternative hypothesis we write as mu d less than 0. Why I write as mu d less than 0? Because we want to test tadi whether the score whether the attending the workshop increasing the test score, meaning that if increasing, meaning that the score before were small or less than the score after. Okay, that's why we write as mu d less than 0, meaning that we are focusing on left tail test. Okay, second step, you need to calculate the test statistic. So the test statistic is given by t equals to d bar minus 0 over s, standard deviation of the difference over square root n. So we get the value of t equals to negative 2.208. Okay, why we get negative? Because tadi kita buat before minus after. Okay, so if you are doing after minus before, here you will get positive value. Okay, step number 3, find the critical value. So since alpha here is 0.05, okay, so you don't have to divide by 2 of the value of alpha, because we are focusing on left tail test. So just refer on your table, statistical table, and find the value of t 0.05 with degree of freedom 6. Okay, why 6? Because 7 minus 1, so we get the value of 1.943. But you have to put the negative value here because we are using left tail test. Okay, step number 4, you need to decide on the decision rule. Okay, so our rules is we will reject the null hypothesis if the test statistic is less than the critical value. Okay, how we come up with this rule? Okay, you can look at this diagram. Okay, so the blue one, okay, the blue one is the shaded region is our rejection region. Okay, so we will reject the null hypothesis if the critical value, if the test statistic value are false in the rejection region. Okay, meaning that we will reject the null hypothesis if the test statistic value is less than the critical value. Okay, so based on the diagram, okay, we will reject the null hypothesis. Okay, since the test statistic value is negative 2.208 less than negative 1.943, meaning that the test statistic value were false in the rejection region. That's why we need to reject the null hypothesis. So we can conclude here the attending the workshop were increasing the test score of the student. Okay, so that itu dalam ayat yang full lah, ataupun in conclusion we can conclude that the score before they attending the workshop were less than the score after they attending the workshop. Okay, maksudnya dia increase lah. Okay, sebab skor sebelum dia attend the workshop adalah kurang ataupun lebih kecil daripada skor selepas dia attending the workshop. Okay, now I want you to proceed or continue example 4.22 and 4.23, and I will give the solution after the class. Okay, but I will continue on example 4.24. Okay, So example 4.24, you are given the Minitab output. Okay, so the example is regarding the 8 teenagers who are overweight are put on a special diet for 1 month. Each teenager is weighed before and after the 1 month dietary programs. The weights of these teenagers are as follows. Okay, so these are example for dependent sample because we are measuring the weight of the 8 teenagers. Okay, first before the dietary program and 1 month later after the dietary program, the weight were measured again. Okay, so we have this raw data set. Okay, and then the Minitab output to test whether the diet program reduce the mean weight of teenagers. Okay, so kalau diet program reduce the mean weight, meaning that the weight before is greater than the weight after. Okay, sebab kita nak tengok adakah the dietary program reduce the weight of the teenagers. Okay, so you can look here the Minitab output. So we have PET-T test, okay, and also the confidence interval. Okay, before that the descriptive value, okay, for group before, so we have n equals to 8, mean equals to 71.1250, and standard deviation equals to 7.4342, and the standard error mean. So standard error mean here were calculated by dividing the standard deviation value with the square root n. Okay, so 7.4342 divided by square root 8, you will get standard error mean value. Okay, and then we have the value for after and also the difference, and then you are also given the confidence interval value for the difference. Okay, and then the test statistic value and also the p value. Okay, so question A, state the null and alternative hypothesis. Okay, so our hash note we can write as mu d equals to 0. Okay, meaning that the mean weight before equals mean weight after, and then the alternative hypothesis we can write as mu d greater than 0. Okay, why mu d greater than 0? Because we want to test whether the diet program reduce the mean weight. Okay, so if we want to look whether the diet program reduce the mean weight, meaning that the weight before they attending the dietary program is greater than the mean weight after they attending the dietary program. So that's why we are focusing on right tail test. Okay, B, show that the mean difference is 2.5. Okay, so how we get the value of 2.5 here? So 2.5 is we can calculate 2.5 value by subtracting the mean before minus mean after, meaning that 71.125 minus 68.625. So we get the value of mean difference is 2.5. Okay, if you are not given the output, okay, so you need to calculate by your own one by one. Okay, you need to find the value of difference for each pair and then find the summation of d and then divide by n, so you will get the value of the mean difference. Okay, C, prove the test statistic t equals to 2.38. Okay, again, why we use t here? Okay, because the sample that are used here are less than 30, meaning that the sample are small. That's why we are using t statistic. Okay, so how to prove the value of t statistic? Okay, if you still remember, the formula is t equals to d bar minus d naught divided by s over square root n. Okay, so the difference, the mean difference, you can take this value 2.5 minus 0 divided by, okay, standard deviation of the difference is 2.9761 over square root n. So we will get the t equals to 2.38. So it was proven the T equals to 2.38. Okay, D, can we conclude that the diet program reduced the mean weight? Okay, so you have two choice here. Either you want to compare the test statistic with the critical value, or you are using the p-value approach. Okay, if the question asking you using the p-value approach, then you have to use the p-value approach. If the question does not mention to use which method, so you are free to use either comparing the test statistic and the critical value, or comparing the p-value and the alpha. So here I will show you the both method. Okay, so if we are comparing the test statistic and the critical value, so you need to find the critical value. Okay, since the significant level here is alpha equals to 0.05, then you need to find the critical value of T 0.05 with n minus 1 degree of freedom, which is 7. So we get 1.895. Okay, and then with the decision rule, reject hash not if the test statistic greater than the critical value. Okay, other than that, you can use the p-value approach. Okay, since you are given the value of p-value in the Minitab output. Okay, so we can write the rule as or we can write the decision as, since the p-value equals to 0.025, which is less than alpha equals to 0.05, then we can reject the null hypothesis. Okay, or you can look at this graph. Okay, so how I draw the rejection region. So the rejection region is the blue one. So our rejection region is or the critical value is equals to 1.895, meaning that if your test statistic value greater than 1.895, okay, meaning that we will reject the null hypothesis. So if we look here, yes, our test statistic is 2.38, which is greater than the critical value 1.895. Then which means that the test statistic value will falls in the rejection region. Then we need to reject the null hypothesis. Okay, so what can we conclude here? We can conclude that the diet program reduce the mean weights. Okay, ataupun in other words, we can say that the weight of before the dietary program were greater than weight after the dietary program. Okay, so meaning that the dietary program were a success, okay, in reducing the weights of the teenagers. Okay, so please complete the example 4.22 and 4.23.